Hello, welcome to the practice lab 6, homework 6. Actually, I finish it, but I forget to recording it. Actually, I recorded, but there's some problem with my sound, so I'm re-recording it. And in this practice lab, we are doing decision trees. And first of all, we are deploying packages. Uh, we deployed NumPy, matplotlib, public test, which is in here, and utils, which is in here. And problem statement is suppose you are starting a company that grows and sells wild mushrooms. Since not all mushrooms are edible, you'd like to be able to tell whether a given mushroom is edible or poisonous based on its physical attributes. You have some existing data that you can use for this task. Can you use data to help to identify which mushrooms can be sold safely? And the dataset uses for illustrative purpose only. It's not meant to be good on identifying edible mushrooms. And there is our datasets, which is given types, red color, I'm sorry, and shape, solidity, and edibility. And we have 10 examples of mushrooms which you have three features: color, shape, and solidity, as I said. And we are labeling as 1 or 0. So it's a classification problem. And one hat encoded dataset is given is in here. If it is a brown cup 1 and tapering shape, talk, stalk shape is 1, solidity 1, and a diable. And like 1, 1, 1, 1. And if it's brown cup, tapering shape is 0, solidity 1, and it's edible is 1. So within this informations, like if it the is given in this for two of them, if it is a brown cup and solidity 1, it we can say it's edible. It is if it is a brown cup and tapering shape is 0 and it's in 0, solidity is, if the solidity is 0, then edible is 0. But we can do it like this one. Therefore, X-string contains three features for each example: brown color, the 1 indicates brown, and 0 indicates for red. And tapering shape, 1 value for tapering stalk shape, and 0 indicates enlarging stalk shape. It's more enlarged, and here more tall. Uh, the other one is only for the solidity, 1 or 0, yes or no. And deuterium metals mushroom is edibility. In here, this is the U column, and we're just running these ones there. And if it's like this one, 111 in here, and 101 in here, 100, and or error or array is 11001, 11001. It goes like this one. And with the variable, let's go more familiar with data cells, data sets. Only it's print.xtrain like 111, 101, 100, 100, and it's giving me, and this is the U train for us. It will give 110010011. Goes like this one in here, as we can display here for the U train. And in here, we are just taking the shape of it and length of the X train. And decision tree refresher, it's like a reminder. In this practice lab, you will build a decision tree based on the dataset provided. Recall that the steps for building a decision tree are follows. Start with all examples at the root node. Okay, we're starting with the root node and calculation information given for splitting on all possible features and pick one with the highest information gain. Split dataset according to the selected feature and create left and right branches of the tree. Keep replaying splitting process until stopping criteria is met. Uh, in this lab, we are following functions. Calculate the entropy at a node. We are calculating entropy and splitting dataset into node left or right branches, given features. Okay, we're just putting the data left or right. Calculate the information gain from splitting on a given feature. Choose a feature that maximizes information gain. We'll then use the helper functions you have implemented to build a decision tree by repeating the split process until the stopping criteria is met. For this lab, the stopping criteria we have chosen maximum depth of 2. Okay, first of all, we are calculating the entropy for it, and the formula is given here. So, uh, entropy, compute entropy, compute the entropy measure of impurity at a node. The function takes a numpy array u is here, is taken here, and diability actually 1 or 0 if it is a diable 1, or poisonous is 0. So it's like a eatable or not eatable. You can assume it's like this one. And compute P1 for the diables, eatables. The entropy is then calculated as, not the log is calculated with base 2, as always in math. For implementation purpose, 0 log 2 0 equals 0, that is a p1 equals 0, or p1 equal 1. Set the entropy to 0, make sure to check the data node is empty. Not empty, I'm sorry. Okay. Please complete the compute entropy function, which is given here. We are, first of all, entropy is equal to 0, and we are taking the length of it, and we are returning as 0. Then we have unique for and return const true, probability const length divided by u. And entropy equal np sum probabilities times np log 2 probabilities. np log 2 probabilities p1, and we haven't defined it over here. Let me run this. I want to check this one. Oops, sorry, I got 4. I couldn't be sure about did I write it true or not. I'm not sure that one. Okay, land here, return 0. What? I couldn't be sure of my code, but okay, I guess it's true. Let me run the other one to the expand. Yeah, okay. The entropy root node is 1, so it is true. I couldn't be sure of my code only. And splitting dataset next. You will write a helper function called split dataset that takes that data at a node and features to split on and splits it into left and right branches. For our decision trees, we are dividing into left and right branches. And okay, the function takes in the training data the list of in the case of data points at any node along with a feature to split on. It splits the data and returns a subset of indicates at the left and the right branch. For example, let's we are starting root node, so indicates 0, 1, 2, 3 to 9, which is the split feature 0, which is whether or not the example has a brown cap. The output function then left indicates 0, 1, 2, 3, 4, 7, 9, and data points which brown cap, and right indicates 5, 6, 8. It is actually like right indicates 5, 6, 8. Basically, right indicates are right examples. Left indicates are the brown cups. So we are dividing the or sample as here, it's actually like this is our node, and this is the right indicates and left indicates. We are doing the left indicates are brown. Actually, not. I don't want to write brown cup here. Okay. Last for the. Okay, I want to do it like this one. Oops. Sorry. Okay. I think is cap. Left indicates brown. Right indicates are red. Let's continue. The please complete split data as function below. And for x indicates features 1, left indicates, and x for the 0 to right indicates. Left indicates and right indicates, first of all, are the empty. And if x index and feature equal to 1, that means we're taking the index like 0 to 9. And if it is the equal 1, we are adding to the left indicate. So we are taking index, and if it is the 1, we are adding it into the left side of it. Otherwise, we are putting it to the right indicate. Actually, this code makes this one. And in here, now let's check the implementation using the code below. Let's splitting dataset root node, which contains all example at feature 0, as we discussed about. We have also provided a helper function to visualize the output of the split. I'm running this one. Yep, as I said, this is actually graph and it's making the same thing for us. Brown is here left side and red for the right side. And in here is it true? Did I forget anything to explain? I guess not. Okay, I guess I didn't. Yeah. Calculate information gain, and we, we are calculating from this formula. And actually, I wrote it over here. And where HP node is entropy at the node, HP left and HP right. Entropy is left and right. So HP left is the entropy of here, and the HP one right is the entropy of the red ones. And proportionate examples left and right branches, respectively. You can use the compute entropy function that implements. Actually, we can use compute entropy as you write over. We can use a split data set. First of all, after we split it, we can use our compute entropy for our divisions, for like the left of the compute entropy, like this one, actually. And I'm running this one. Yeah, okay. Information gain from splitting root brown cup and solidity and stock shape is here. And get best split is function below. Uh, okay. The function takes in the training data along with the indicates of data point at any node. The output of the function feature that gives the maximum information gain. And function iterate through to features and calculate the information for each feature. If you get stuck, okay. Actually, I get stuck and I check the code in here because I couldn't write myself. Because I didn't purely understand what is the function doing. But after I checked, I guess it must be we are taking the shape of x and we are using the compute information gain over we write Where did we right here? We are using this one, splitting data set, calculating the entropy, and we are using the information gain and from the splittings. And best feature after we run it, we're taking it and split on 2 and get best sublet test get okay, if I print it, what I will take it. Let me check it. Don't forget anything. Yep. Okay. I just want to try it. I wasn't be sure what I will take it, but okay. In this section, we use the function you implement above the generates a decision tree by successively picking the best feature to split on until we reach the stopping criteria. Maximum depth is 2. No need to implement anything for this part. Okay, so yeah, just running this one, and I'm running this one actually. Okay, split on solidity. We are taking this is a solidity for us. Like we're doing it like okay, I want to close it and I want to open the paint again. In here we have the all data sets, all, and we're dividing it into two with the I want to check for more type. Okay, for a second. Okay, the left side about not brewing cup, we are dividing for solidity. I can say it like solidity, and if it is 1 and 0 here, if it is solidity 1, so I mean if it is eatable, it's on the left side. If it is not eatable, on the right side. And in here we are dividing by the cup. If it is brown, it's on the left side, and if it is a red, it's in the red side. In here we are dividing by the color again, cup. Yeah, actually we cannot divide in different things, so I can write cup in here, and it's a red in here on the left side, and brown on the right side. Okay, I'm not sure why did I explain like this one. And okay, the experiment with okay, yeah, okay. And thanks for the listening. Have a good day.